Welcome back to our last portion of data structures and operations, linked list. So we have already studied about linked list in the C++ portion of structures. So in the portion of structures we have studied a linked list can be created with the help of a self-referential structures. Okay, so here I have drawn a linked list, an example of linked list. Here I have drawn 4 nodes. This is known as nodes. So here each node is created with the help of a structure. So in the structure there contains 2 data members. The first data member will be of integer data type and the second data member will be a pointer which points to itself. Okay, so that's the meaning of the linked list implemented with the help of a self-referential structure. So here we have created 4 nodes. The first node contains the data 25 and the second portion is an address portion which points to the same structure. So next same structure means next node will be created. Okay, so in this portion the address of the second node will be stored here. Clear? And in the next node 34 is the data and in the second portion an address is stored. That means an address which points to itself, means third node will be created. So the address of the third node will be stored in the second node. Okay, now in the third node the data 17 is created or is inserted, and in the second portion also it contains the address which points to itself. That means the fourth node is created. So here the address of the fourth node, whichever is the address is of the fourth node, that address will be created in the address portion of the third node. Now see here the address portion of the fourth node is null. That means no other node or the address does not point to itself. That means the linked list is stopped here, or we have stopped creating nodes for the linked list. So this is an example of the linked list. Here I have created a node. For example, I have given the name start. So this node is used. This node is used to only to store the address of the first node. So start node is used to store the address of the first node. Okay, so what's the specialty of linked list? Any number of data items can be created. There is no limit in the number of data items. If I want to create 1000 data items, 1000 data items can be created with the help of a linked list. And what's the specialty of this linked list? It is a dynamic data structure because the data are inserted at the execution, not before the execution. The data are inserted at the time of execution. That is a specialty of linked list. So that linked list can grow or linked list will expand when the data items are added, and if we are deleting each data items, the linked list will shrink to its to the number of data items based on the number of data items we have deleted. Okay, so linked list is a dynamic data structure and it grows when the new items are added and shrinks when the data items are deleted. So since this is a dynamic data structure, we know that memory cannot be allocated in advance. Memory will be allocated for each node only at the execution of the program. Okay. Next point is elements in the linked list are scattered in memory but linked with each other through pointers. We know the specialty of the linked list. Each node need not be stored in the consecutive memory location. It can be stored anywhere in the memory, but each node is linked together with the help of this pointer. Whereas in the case of array, we know that array is a data structure in which data are stored in consecutive memory location. Whereas in the case of linked list, data can be stored, means each node can be stored anywhere, but each nodes are linked with each other with the help of this pointer. Clear? We have already said the first node contains the second portion of the first node contains the address of the second node. The second portion of the second node contains the address of the third node. So they are linked together. First node and second node is linked together with this address. In the similar way, second node and third node is linked with this address. In the similar way, third node and fourth node is linked with the address portion of the third node. So even though the nodes are scattered in memory, they are linked together with the help of the pointer. Clear? Next one is, I have already explained, each node contains the data. This is the data portion, and the second one is the address of the next node, and the second portion contains the address of the next node. Clear? Okay. Now the next point is, I have already said there is a special pointer known as start. This start contains the address of the first node. Now the last point is, the memory space allocated for each node will be the same, because each node, the address of each node contains the address of the next node. Okay, the address portion means the address data member of each node contains the address of the next node. So each node always stores or always takes only the same amount of memory. See here, the first portion contains integer data, here also first portion contains integer data, here also first portion contains integer data, here also first portion contains integer data. And the second portion contains the address of the next node, second portion contains the address of the next node, second portion contains the address of the next node. So each node always occupies the same amount of memory. Clear? Okay. So next we are going to look how we can implement this linked list. Okay. So I have already explained the linked list is implemented with the help of which structure? Self-referential structure, because self-referential structure is a structure in which one of the data member points to itself. So here also the second data member points to the itself, means second data member points to the same structure definition. That's the meaning of itself. Okay, so linked list can be implemented with the help of the self-referential structure. Now we are going to look how we can use a code to implement this linked list. Here I have written a simple example. Here I have created a structure named node. I have given the name of the structure as node. See, first data is of integer data type. First data is of integer data type. Second data member is a pointer which points to itself. Okay, so here link is a pointer which points to itself, means link points to node itself. Here node is the name of the structure, so link points to the same structure. This type of structure is known as self-referential structure. So each node can be implemented with the help of the following code. Okay, so in the similar way that we have already said, a start is a special pointer. A start does not contain any data, it only contains the address. Okay, the data portion of the start is null or 0. Okay, so this is a special pointer. The special pointer start that points to the first node can be created by using struct node start, because this is a pointer which contains the address of the node data of the node structure. Okay, so the first pointer, this can be called a start or header pointer. Two names can be used for this pointer, start or header. Start pointer points to the address of the first node. So that can be created with the help of the statement struct node start. So this pointer contains the address of the structure node. Okay, that's the meaning of this statement. Clear? So next we are going on to what are the various operations on linked list. So first let's start with the first operation, creation of linked list. So here I have drawn an example. I want to create this structure. Okay, I'm going to see how this structure is created. This is an example. Here start pointer should point to the address of the first node. This is the first node. The first data should be 25 and the second address portion should point to the address of the second node. Now second node contains the data 34. The second portion of the second node should contain the address of the third node. The third node should contain the data 45 and the last should be the last portion or the address portion of the 45 should be stored with null. That means the linked list is creation of linked list is stopped with 3 nodes. Okay, so we are going to look how we can create this linked list. Okay, so in the first case the value of start is null. That means no nodes are created. This means linked list is empty. That means we have not created any node. It does not contain any address. The address is null. That means it does not point to anything. That is the meaning of null. Okay, this is the first case. And in the second case, I want to create the first node. So first I am going to create the node. So while creating the node, while creating the single node, the node data should be 25 and its address portion is null. We are just creating the node, so its address portion is null. Okay, so after creating this null, what we are going to do, after creating the first node, what we have to do to create the linked list, we have to link the address of this node to the start pointer. Okay, the address of the first node should point to the first start pointer should point to the address of the first node. Assume the address of the first node is 2000. So instead of null, now the start pointer should contain 2000. So what's the meaning of this 2000? This 2000 point is the address of the first node. Okay, so the start links to the first node. First node is created. Okay, now again we are going to create the second node. In the similar way, the data portion is 34 and the address portion is null. Okay, now we are going to add this node to the linked list. So here what we have to do for the first node address portion, we have to fill the first node address portion with the address of the second node. Okay, so assume the address of the second node 34 and null is 2500. So the first node address portion, in the previous case the first node address portion was null. Now when the second node is to be added, the address of the second node, that is 2000, assume 2500, will be stored in the first node. So this is the diagram of linked list when the second node is added or created. Okay, now we are going to create the third node. So the third node creation is done. Data portion is 45 and the address portion is null. Okay, now we are going to add this 45 to our existing linked list. So in the previous case, the existing linked list, in the case of second node, the existing previous case, the address portion was null. Now to add this third node to this linked list, we have to fill the null portion of the second node with the address of the third node. Assume the address of the third node is 3078. So the address portion of the third node will be filled with 3078. That means it will be linked to the fourth node because 3078 is the address of the third node. Clear? Okay. So now we are going to look what is the algorithm of creating a node. It's a very simple algorithm. First, what we have to do, we have to just create a node and obtain its address. Okay, so first the node is created and its address should be obtained, or we should get the address. Now we are going to store its data and null portion in the node. So that in the first case, while creating the node, the address portion should be filled with null. Now what's the third step? Assume if it is a first node, what should be done? The first node address should be stored in the start, because in the first case we know that the start pointer contains the null. So when the first node is created, the start pointer should be filled with the address of the first node. And if it is not the first node, that means if it is the second, third, fourth, fifth nodes, what should be done? The link the portion of the link part of the previous node. Here, see this example. If I want to create this node, the link the portion of the previous node should be filled with the address of the next node. Okay, so if it is not the first node, the link the portion of the previous node should be filled with the address of the next node. Okay, so this step should be repeated as long as we are adding each nodes. Clear? Okay. So we have looked how we can create a linked list. Now we are going to look how we can traverse a linked list. So what do you mean by traversing? We have already studied about traversing in the operations of structures, operations related to structures. The one point was traversing. So traversing is a process of visiting the data structure is known as traversing. So here also the same meaning, we have to identify each data and print each data, or in other words we can say we have to program control should pass through each node, that is known as traversing. Okay, so what will be the algorithm of traversing? First we have to go to the first node. First we have to get the address of the first node. So from where we can get the address of the first node? The address of the first node is stored in the start. Clear? So first what we have to do, we have to get the address of the first node from the start and store it in a temporary variable named temp. Okay? Once again I repeat, first we have to get the address of the first node. We can get the address of the first node from the start. So that address is stored in a temporary variable known as temp. Okay? And now using that address, we can access the data of the node. Okay, so any data is stored in a variable val and that can be printed. Okay, now if the node is not a first node, how we can get the address? We can get the address from the first portion of the previous node. To get the address of the second node, we can get the address of the second node from the address portion of the previous node. Okay, similar in the same way, this address is also stored in the temp. Clear? Now using the address of the temp, we can get the data of the second node. In the same way, the process is repeated till the address portion in the temp becomes null. Okay, till it becomes null, that's the same process will be repeated, so that each data, when the address portion of stored in the temp will be accessed in the temp will be null, that means the linked list have completed its node, or linked list is stopped there, so there is no need to go for the traversing operation. We can stop the traversing operation there. Okay, that's the meaning of null. Or any other nodes are not stored in the linked list, so we can stop the traversing operation by looking whether the address stored in the temp is null or not. Clear? Okay. So we have completed the two operations. Next we are going to look how data can be inserted into a linked list. So what do you mean by insertion? It is a process of adding a node to the linked list. That is the meaning of insertion, the process of adding a node to the link, or anything, any structure is known as insertion. So in the case of linked list, insertion can take place in three locations. First, the data can be inserted as the first node. Second, the data can be inserted as the end node. Third, the data can be inserted in between the nodes. Either it can be inserted as the first or the last, or it can be inserted in between the nodes. Okay, so first we are going to look how data can be inserted at the starting position. Okay, so this is the linked list before insertion. This example is a linked list before insertion. Now assume I want to add a data 55 or node with value 55 in the front of the existing linked list. Okay, so this 55, I have to create the node 55 with the address portion as null. I am going to create a node. Next, after creating, I have to insert this 55, this node 55 should be placed before the first node 25, first node which contains the data 25. So what should we do? Here the start pointer contains the address of the first node which contains the data 25. Okay, now if we are going to insert this 55, the node which contains the data 55, this address should be changed. Okay, so this what should be this address of the start pointer? The address of the start pointer should contain the address of the node which contains 55 data. Okay, now assume the address of the node which contains 55 data is 3000. Okay, so the start pointer should contain 3000, but before this 3000 is stored in the start pointer, we have to copy this 2000 to the null portion of the to the address portion of the adding node. Why? Because 55 and the first node is 55, and after the first node 25 comes. So the address portion of 55 should contain the address of the node which contains 25. Now the address of the node which contains 25 is stored in the start pointer. The first process that should take place is we have to fill the null portion with the address with the existing address stored in the start pointer. So that is the first step. Okay. So 55, the address portion of the 55 is now changed from null to the address stored in the start pointer, the existing start pointer. Okay. Now the start pointer is free now, or it is blank now. Okay. So now we can store the address of the node which contains the data 55. That is, for example, 3000 can be stored in the new start point. So the linked list after insertion will be 3000. That means the address of the 55 node which contains 55. So it points to 55. Now the 55 contains 2000. The value that was stored in the start pointer is stored in 2000. So it points to the previous first node and the existing second node. Okay, remaining all are the same. So this is how we are storing the data at the start. We are inserting the data at the starting position. Okay. So now we are going to look how we can insert data at the end of the linked list. In the previous case, we looked how to insert data as the first node. Now we are going to look how we can insert data as the last node. Okay, this is also an example of linked list. The same example I have drawn here, the linked list before insertion. So here also, if I want to add the node which contains 55 data at the last position, the first thing I have to do is to create the node. So I have created a node with data 55 and the address portion as null. Okay, so and assume the address of the data which contains 55 is 5000. Okay, so what should be done now? The linked list before insertion contains the node. The last node of the linked list before insertion was 45 null. Okay, so here the address was null. That means there is no other nodes in the linked list. Now we are going to add this 55 and the null to this linked list. So here what should be filled? This portion should be filled with the address of the new node. Okay, now assume the address of the new node is 5000. So here what will come? 45 5000. And after 45 5000, which should be placed 55 and null should be placed. So linked list after insertion is 45 5000. That means 5000 is the address of the node that is inserted. Okay, so it will point to the 55 null, and in the last case here it is null because no further node is inserted. Okay, so this is the way we are inserting data to the end of the linked list. Clear? Okay. Now we have to insert data at any position of the linked list. So we have completed looking how to insert data at the starting of the linked list, at the ending of the linked list. Now we are going to look how to insert data at any position in the linked list. Here also I have drawn the same example, and I am going to insert the node 55 null, but this 55 null should be inserted as the third node, that is between 34 and 45, which should come, 55 should come. Okay, so what should be done in this process? So we know that 34 and 3078 is the address of the node which contains 45 data. So the new node should come between 34 and 45. Okay, I have drawn here 55 and null should come between 34 and 45. So what should be done? This 3078 is the address of the 45 node which contains 45. Now that should be replaced with the address of the node which contains 55. Okay, assume here I have assumed the address of the node 55 is 6000. So here it should be filled with 6000. So before 6000 is filled here, 3078 should be copied to where? Should be copied to the node which contains 3078, because 55 after the node which contains the data 55, it should point to the node which contains the data 45. The address of the node which contains the data 45 is 3078. Okay, so this data 3078 should be moved to the null portion of the node 55. So first the 3078 is moved to the node which contains 55. Now this is free here. Now we can insert or store the address of the new node, that is 6000. So after the insertion, the linked list will appear as follows. Clear? Okay. So we have completed the 3 operations, and the last operation is deletion from linked list. So this is also very simple. Here I am going to look how we can delete a node from the linked list. Here also 3 types of deletion can be performed. First can be the deletion of the first node, second can be the deletion of the last node, and the third can be the deletion of node in between the first and the last. So first we are going to look how we can delete the first node. Here I have given an example, the same example I have given here. Now I am going to delete the first node, that is 25, the node which contains the data 25. Okay, so what should we do to delete the data 25? We have to just move this pointer to the second node. So this data will be deleted. So now the start pointer contains the address of the first node, that is address of the node contains 25. To delete this node, what should we do? We should store the start pointer should contain the address of the node which contains 34. That is, the address of the node which contains 34 is stored in the address portion of the first node, the previous first node. Okay, so this 2500 should be stored in where? The start pointer. Okay, so 2000 should be replaced with 2500. Clear? Now by replacing, we can delete the first node. Okay, now we are going to look how we can delete the last node. How we can delete the last node? Here we know that 3078 is the address of the last node. We have to delete this last node. So the last node should contain only null. If we have placed that address as null here, that means further there is no any node. That means the last node is deleted. The existing last node is deleted. So we have to just place null in the n-1th node. Assuming these are n, there is n node. Here I have created 1, 2, 3 nodes. So to create to delete the third node, I have to place null in the address portion of the second node. So if there are n nodes, the address portion of the second node should be stored with n-1 node should be stored with should store the address as null. Okay, that's how we are deleting last node. Okay, next we are going to look how we can delete a node from any position in the linked list. For example, I want to delete the node which contains the data 25. It's very simple. What we have to do, we have to just move the pointer of the previous node to the next node. Okay, so if I want to delete 34 and 6000, 34 the node which contains 3000, I have to move this pointer to 55. That's the only way to delete this node. Okay, now this 2000, the address of the previous node, I have to delete the second node. So the address portion of the previous node contains the address of the node which is deleted. For example, 2500 is the address of the node which contains 34. Okay, so if I want to delete this node, and I have to delete the address portion of the previous node to the address of the next node. Okay, so the address of the next node is stored in the data which is to be, the node which is to be deleted. So what we have to do, we have to remove this 2500 and copy the address portion of the node to be deleted to the address portion of the previous node. Okay, so here what will be the address portion of 25? The address portion of the 25 will be 6000. So since it is this 6000, it will automatically point to 55 because 6000 is the address of 55. So what happened here? Here the node is deleted or the node is removed. Okay, so the new structure will be 2000. 2000 is the address of the first node, so it will point to first node. Now the address of the first node have changed from 2500 to 6000 because 6000 is the address of the node which contains 55. So it will automatically point to 55. Now we have removed the node 34, the node which contains 34. Okay. So hope all of you have understood the various operations on the linked list. Now we have completed our portions of data structures and operations. So in the next class we will be dealing with the next new chapter. Thank you.